Beautiful species in the house, welcome. Chem 122, second semester organic chemistry course. We have been discussing the man we call isomerism. Now we have gotten to the stage we call tautomerism. Tautomerism. This person does not mean what it sounds like. I need you to pay special attention. Class, take a close look at this. If I write something like CH3, OCH3. You notice that this person obeys the general formula ROR. That's the formula it obeys. This R represents an alkyl group. Alkyl group, which is alkane that has lost one hydrogen atom. For instance, the first member of alkanes is CH4, which is methane. If methane loses one hydrogen atom, it becomes CH3. So whereas we call this person methane, the first member of alkanes, this person here is called methyl. So methyl is an alkyl group, alkane that has lost one hydrogen atom. In this course, we denote it with letter R. All alkyl groups are denoted with letter what? R. Take special note of that. So where I have CH3OCH3, it means that I have two alkyl groups separated by the ozo group. Now, any organic compound that obeys the formula, that conforms with the formula ROR, where two alkyl groups are separated by the ozo group, belongs to a class of organic compounds we call ethers. Ethers. So if I want to name this compound now, I will look at it closely. You see that this is a methyl group, this is a methyl group. There are two of them. So the name will be dimethyl. Then I'll end it with ether, knowing that it obeys the ether general formula, ROR. Again, I want you to take a close look at this one. Watch this person. If I represent C2H5OH, you will agree with me that C2H5 is an alkyl group. Alkyl group. Because this man here represents ethane that has lost one hydrogen atom. Ethane is supposed to be C2H6. That's the second member of alkanes. So when he loses one hydrogen atom, it becomes C2H5. So this C2H5 is an alkyl group, which we can denote with letter R. So it means that this structure I have represented here obeys the formula ROH. So it belongs to a class of organic compounds we call alkanols. So if I want to name it, I will name it as ethanol. Et, because I have two carbon atoms in the structure. This R here is because it's a substituted alkane. All the atoms in this structure are linked together by single sigma covalent bond. So it's a substituted alkane. That's why we say A. Assuming there's a double bond in this structure, I will say 80. Ethanol. So since I have two carbon atoms, I will say et. The A is because it's a member of substituted alkane. Everything I have in this structure, if I expand it, is single bond. That's why I say A. Then this null suggests the presence of hydroxy group, which places it in the class of alkanols. No wonder you say ethanol. Now, I want you to take a close look at this. How many carbon atoms do I have in this structure? Two carbon atoms, C2. How many hydrogen atoms do I have? 3 plus 3 will give you 6. That is H6. How many oxygen atoms? 1. Only 1. So you see that the molecular formula is C2H5O. 2 carbon atoms, 6 hydrogen atoms, 1 oxygen atom. Let's do the same thing here. How many carbon atoms do I have? 2. How many hydrogen atoms? 5 plus 1. That is 6. How many oxygen atoms? 1. So you see that the two of them, they have the same molecular formula. But they are structurally different because they have totally different names. So it means that dimethyl ether and ethanol are structural isomers belonging to the subclass we call functional group isomers. In our discussion of isomerism, we said we have three types of structural isomerism. Three types: the chain, the position, and functional group isomerism. All under the class of isomerism we call structural. So these two people you see here, dimethyl ether and ethanol, are functional group structural isomers. Are you with me? They have the same molecular formula but different structures. They differ structurally in their functional groups. Why this person has the ether functional group, this person has the hydroxyl functional group. Does that make sense, somebody? So what do we call functional group isomers? Isomers of the same organic compound with the same molecular formula but differing structurally in their functional groups. Isomers of the same organic compound with the same molecular formula but different structures in their functional groups. Now, in this chem 122.2, anytime you have two functional group isomers that exist in dynamic equilibrium with each other. Hey, I hope you know in our first semester we talked about chemical equilibrium. When do you say chemical equilibrium is established? In a reversible reaction, when the rate of forward reaction becomes equal to the rate of backward reaction, equilibrium is established. Dynamic type of equilibrium. Now, in this second semester, chem 122, Tautomerism is the man of the moment. When you see two functional group isomers, which I just explained now, two organic compounds with the same molecular formula but differ structurally in their functional group, if you have two of them existing in dynamic equilibrium with each other, then you have what we call tautomerism. A typical example is this. Take a look at somebody like this. What do I use? Okay, let me say I have CH3. Then I have CO, then this is H. This man obeys the general formula we call arocho. Arocho. This CH3 is an alkyl group, so I can denote it with letter R. Then what is remaining? COH or CHO. That is cho. Arocho. You have the alkyl group, you have the carbonyl functional group, and then you have hydrogen here. It obeys the formula we call arocho. And any organic compound that conforms to the formula arocho, or if you like, arucoH, belongs to a class of organic compounds we call alkanals. Alkanals, we're coming to that. So if I want to name this person now, having known that it obeys the alkanal functional group, the name must end with nal. So all I need to do is to count the number of carbon atoms. There are two of them. So I will start the name with et, eta, ethanal, 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 if you like, ethanal, representing an organic compound obeying the alkanal general formula, having the alkanal functional group, or what we call the carbonyl functional group, having two carbon atoms in it. That's why I say ethanal. Now, take a look again at this person. I want to show you something. If I write this one, watch me. I'm going to somewhere. Follow me. Take a look. I think this structure is in order. Yes, it is. Remember that for any organic structure to be correct, each carbon atom must be surrounded by a total of 4 bonds. 1, 2, 3, 4. 1, 2, 3, 4. So it's in order. Now, if you look at this structure here, I have 2 carbon atoms. So my name will also start with et. But you notice that there is a double bond here. So it's a substituted alkene compound. So I will say et. Not ether, but what? Et. Then I will end it with what? Nol. So whereas this one is ethanal, this one is ethanol. Et. 2 carbon atoms. E double bond. Null because of hydroxyl group. So this is ethanol. Now class, but there's something here. How many carbon atoms do I have here? 2. So I can write C2. How many hydrogen atoms? 3 plus 1. That's 4. So I can write H4. How many oxygen atoms? 1. Let's take a look at this one. How many carbon atoms are here? 2. So I can write CO2. How many hydrogen atoms? 1, 2, 3, 4. So I can write H4. How many oxygen atoms? 1. So what is the implication? The two of them are actually isomers of the same organic compound. They are the same organic compound, existing in different forms with the same molecular formula, but they differ structurally in their functional groups. This one has the carbonyl functional group, while this one has the enol functional group. There's a double bond and there is a hydroxyl group. Class, are you with me? So these two men are functional group isomers because they differ structurally in their functional groups. And they are existing in dynamic equilibrium with each other. A phenomenon we call in this course tautomerism. So what is tautomerism? A situation where two organic compounds or two forms of the same organic compound, one organic compound existing in different forms with the same molecular formula, different structures, and the structures differ only in their functional group, and at the same time they are existing in dynamic equilibrium with each other. So tautomerism occurs when two functional group isomers exist in dynamic equilibrium with each other. Did you understand? It's time to work. Second semester is on the way. God bless you.